Good morning. Welcome back to
Here we are.
Collision World's Fair. We just got done with the happy hour from last night.
Yep.
That was a good time.
Yes.
Well, it's kind of fun that after we turned the cameras off, we just kept going.
Yeah.
Yes. And we haven't slept, so
yeah, exactly.
we're gonna have some issues today.
Which may show why some of these welds look like they do, perhaps.
Yeah.
So today we're going to talk about weld strength and some of the factors that go into it, why it's important, certainly. And obviously we've got a lot of knowledge up here with these two guys to talk about steel, aluminum, spot welding, Mig Brazing. I mean, we could probably talk about this for a couple of days. We're going to try to keep it to an hour. So try to keep that in mind, Larry. We'll try to keep you on task the best we can. Well,
Why do I always get the blame?
Well, it's because it's your fault usually.
Oh,
If
I
you watch the
see.
previous videos, you'll see why.
Yeah.
Oh, I
Yeah,
see.
yeah,
Okay.
yeah.
Being a little judgmental here.
Yes, we are.
We are.
Yeah.
Yeah,
I can
that's
hear
well-
you. I'm standing here like, use your inside voice.
Yeah.
Wait, let me turn my back to you so you can talk about me.
So what we really want, I mean, last night we kind of focused on a lot of the bad stuff that we see,
Yeah.
right? And we talked about a bad repair the other day. Today we want to talk about good repairs. Now we're going to have some bad examples, but we want to talk about why they're bad examples and what we need to do to correct them on our next weld.
Well, we have good welds and we have some bad ones.
Yep.
And we showed the little differences, and you did a good job of writing stuff down that you did on each one of these so we can do a explanation of machine settings and even your own personal
Yep.
movement and settings.
Which we learned. So I got a little education this morning. I was having some troubles on something that we'll talk about when we get to it. But Larry and Mark coached me through it, and then I'm like, oh, you know what?
There we go.
That's exactly what I did. So
You know, before we get going, let's just kind of set the premise here.
yeah,
So, Larry, you said this for years. You've said nobody in our industry is a professional welder. And because professional welders weld all day long every day.
That's their job, just to weld.
Yeah,
I mean,
that's
we
what
don't
they
weld
do.
that much.
And we don't weld really that much, so therefore, you know, it's like professional basketball players. They practice, then they go to games. And unfortunately, in our industry, people go in and they start welding without practicing. And so how much practice do you think people really need to jump on? You're going to put a quarter on a car, you haven't welded for a few days. How much practice do you think somebody should really do?
Well, if you're somewhat proficient and you've passed some sort of welding qualification test and or have been a welder maybe in the military, you know, and you have a principle, you get rusty like anything else.
sure.
Like riding a bike, you don't forget it, but how many of us have really been on a bike lately outside of a stationary bike? You know, go to ride a bike, you might get on there and go, well, wait a second.
I'm not going off the jump like I did when I was 12.
This is a little bit different. I'm not,
Yeah.
okay. And then like in 10, 15, 20 minutes, you're comfortable and you're riding again.
Yep.
With steel, you could probably become, you know, better proficient than you were because you haven't been doing it for, you know, a couple of weeks or whatever, and probably a half hour, 40 minutes. All right, I'm back to it. If you haven't welded in a few months or a year, it'll probably take you a day just of, all right, I got the machine settings back, I got my comfortability. It's really, and we're going to talk about it later, it's your body position and your elbow. Almost like, and I'll talk about it later, equated to shooting pool. It's the mechanics of like shooting pool. If you keep the basics, you'll do a good weld. So probably like once a week. You know, you practice for an hour or two. Silicone bronze, depending on the type of silicone bronze weld you have to weld, especially like if it's an overhead, you probably need like 2 days, couple of hours practicing, you know. So steel would be maybe 1 day a week, 2 hours. Silicone bronze might be 2 different nights of maybe 2-3 hours each. Aluminum, you're talking 5-6 hours a week you need to practice to keep
let's
proficient.
go a little bit in depth on the aluminum towards when we get to the
yeah,
aluminum.
towards the end,
I
yeah.
want to talk about some of the OE programs that you've
Oh, yeah,
gone
right.
through and the strength. And starting with, I mean, here we've got some good welds from Larry. So we hassle Larry a lot, but let's give Larry his due as well. So this is your most recent. That's a good
thanks.
golf clap for Larry.
You know, and one thing I do want to just kick back to is the reason why we're doing the weld strength show is because obviously cars are being held together with welds, and if we're not practicing, our first, you know, few welds may not be good, and so we need to do weld test, destroy them, and then all that. And so we're going to talk about the mechanics and stuff of it, but as an industry, I hate to say it, but we don't weld good as an industry.
Yeah.
And it just goes back to practice. And
Yeah.
we'll talk about aluminum at the end, but with aluminum, you got so much more because it's got to be clean. But in like this case here, this is my Mercedes-Benz welding test I recently took. And those 4 plates that are in the back there, the really long ones, the 300 millimeter ones, I think that's 10, 11, 12, and 13 that I made. The rest, the first 2 or 3 were good, I had a little divot in one spot. Or I had a little suck back in one spot. It's like, oh man, 300 millimeters, and I got this one, and that took that. The T-welds are pretty easy. The T-welds, I made 2 practice, and then I blew out all 4 of those. And the cast ones are basically, I just make them and I start welding, and you know, I might have one bad one out of the 5 or 6 I make, and then they're ready to go. And then I choose which ones I'm going to put in for testing. So it's a little nerve-wracking, you know, to do it and stuff, especially the overhead 300 millimeters. I'm an older guy, I'm in my 50s. My shoulders hurt from years of boxing and just abuse in the shop,
Bar
laying on
fights.
concrete
Floors.
floors, you know, lifting things without my back, you know, without my legs, and just, you know, your shoulders hurt, and you got this big, huge plate you got to keep bolting it to. So it's this kind of motion constantly, but you're doing it 12, 13, and it just, and then you're welding like this. So, you know, it's a younger guy's job in a way, you know, so it can be nerve-wracking, but the practice comes in handy.
Yeah, and I still want to dive a little bit more in aluminum when we get to it, but you know, I want to take a little bit of a different approach to your question, Larry, about like how often you need to practice. I can appreciate where he's coming from, and I don't disagree with any of that. For me, the most important thing is that you practice before you weld in the car.
Absolutely.
And you've got everything where you need to be before you make that transfer. And this afternoon, we're going to talk about practice welds and why, you can see a bunch of coupons that we made here, why I don't want to take this and then jump over to the car. So we're going to talk a little bit about this afternoon. But that's my answer to your question.
Well, one of the premises is that if somebody were to look at the title of this show, they go, oh, weld strength. I already know everything there is to know about that. I've been doing this 30 years, no need to watch that. So that's why I wanted to throw that premise in right off the bat.
Cool. Okay, so let's start, with like the most basic thing, right? We need heat, right? To make a weld, we need some heat. We're gonna have to fuse these 2 pieces together. So I wanna talk about penetration, good penetration, bad penetration. I wanna talk about the heat effect zone around the weld. Talk about high strength steel and ultra high strength steel. Again, we kind of made light of it last night where cars haven't changed for 15 years other than aluminum. Well, we know that that's not the case. So I want to talk about that a little bit, and I want to kind of also talk about the Nissan requirements for it. But let's start with weld settings and weld heat, first of all. So the first thing we always say when we want to make sure that we've got the machine dialed in for the material thickness that we're welding. When we're making our practice welds, we're going to make the welds on the same type of thickness and the same position. Now, the first place to look for to figure out how thick of a material am I welding on is the OEM information, correct? So we're going to go into the body repair manual, find out whether it's 16 gauge, 18 gauge, 22 gauge, or something different. And if for some reason maybe the OE doesn't have published procedures on it, then we can look to something like a welding gauge here. So Miller's got a nice little keychain welding gauge. The iCar's got their plastic
gap gauge. You can use a veneer or
calipers or whatever.
You know.
So if I've got an OEM coupon that I don't know what the thickness is, I can quickly come in and make my. It's hard to do it here on camera, but I'll just kind of, right? I can just kind of come in and figure out, so that's definitely not 14 gauge, not 18 gauge, pretty loose yet. And I start getting, that's maybe 20 gauge, 22, maybe 22 gauge. So again, so now I know kind of what I'm dealing with from a thickness standpoint. Let's prop that up for you, Avery, maybe here, if I can, maybe not.
It's okay, I'll hold it.
All right.
Try and do it that way.
So now I know I've got, again, whatever thickness of material that I've got, and then I can look at that OEM procedure and say, well, what electrode wire do they recommend? And more often than not, again, if I'm dealing with 22 or 20 gauge, ER70S6 or 3, 024, 023, depending on your material supplier. If I start getting a little bit, thicker material, 16 gauge or 1/8 inch or something, now it might be 030, 035, kind of the high end for steel.
For steel.
So we're typically dealing with 023, 024. 030 or 035 are going to be kind of the most three.
And the ER70S-6 or 3. Depending on what manufacturer.
So now I know I've got my electrode wire, I've got my material thickness. Now I can look inside of you want to open that door maybe and turn that side? I can now open up my welding chart, my welder, and sorry about that, Mark. And look and see, now I can reference and see where should I start my settings. Now, I think it's obviously a great place to start, and I'm going to fine tune from there based on how fast I'm going to go, how slow I'm going to go, maybe my own personal technique, stick. There's a lot of variables, so this is just the base part of it. And then this particular machine has the auto set feature on it as well, that you can just set the material thickness, the electrode wire, and the material thickness for the particular welds you're going to be making. So what
Which
are
is
some
not
of
a substitute for test welds before you
not
work on the car.
Right.
Correct.
Yeah.
And again, same thing there with the auto set. We can still fine tune from there. But I mean, I love the auto set on the Miller machine, and obviously the charts from the equipment makers makes it a little bit easier to know exactly what I'm going to have to deal with. But
Just kind of gets you over the target.
what are some of the what are maybe some of the variables or hurdles that I might encounter in that process of identifying the material and then looking on my chart here and setting up? What are some of the things that might happen that maybe could go awry?
Well, I mean, you have a definite substrate difference between a mild steel panel, a high-strength steel panel, high-strength low alloy, or even a ultra-high-strength martensite or boron alloyed steel type material.
Yep.
That you have to take into consideration. They're going to weld differently. Also, there's, I think GM has a panel that's coated, like one of the reinforcement panels that was a little difficult to weld. And you had to super, almost like aluminum, you had to super clean it down really well to be able to actually get a good weld with it. If anyone's ever had some of the galvanized type steel that you see like in your heating ducts, and you try and weld that, it's next to impossible to weld it. You know, it almost looks like it's got like a little starburst type silver spray paint on it.
You got to get it off.
Yeah, and it's
Yeah.
very difficult to get off because
Yeah.
that's how that material is made. It's not painted, and that's why you always see it's raw metal versus these, which are galvanized.
Right.
Excuse me, that's galvanized. This is galvanized.
Galvanized.
It's a little bit different of a product, so that causes an issue when you're trying to weld. Your weld position, obviously, also causes some different things with gas movement or body position or even gun angle. Sometimes you have a tendency, just like spraying a panel. If I'm not, my arms aren't long enough to spray over there, so if I'm spraying, I might
Pick
do
it
one
up.
of these things at the
Yep.
end versus you're a taller guy and get a full thing. Same thing with the welding. If you don't move your body position as you go, and it's still very difficult because spraying with paint's a little more forgiving than welding something that's hot that's melting into something else. So you really you almost gotta practice the movement 2 or 3 times before you're ready to weld.
That's
so
the
that
mechanics.
Yeah, it's just the mechanics. Keep the basics. Your movement, your body positioning is always a very important thing that will affect weld bead, weld pattern, weld height, weld penetration on the backside, even your heat. If I got the settings real low and go slow, I'm still going to burn through it. If I go real fast with a high setting, I'm going to have no penetration.
Right. Yep.
You know, so everything gets factored in. And if you read iCar's class or you read the welding thing I've gone over, basically we use the stuff like from Miller or Lincoln. They show you, well, porosity is this or this, like the gas is off, there's a hole in the gas line, the gun's, you know,
Pinched or
let's
something.
bring it back to let's get back to the thickness part of it. We'll talk about porosity in a little bit.
well, the point I was trying to get to is they say mechanics on that.
Yeah.
And then the last thing is the technician.
Yeah.
And it's always the technician with that. And it's sometimes you don't go with the type of material you have.
Right.
Sometimes you have a thicker and a thinner,
Yeah.
which I know you have some examples of that. And that changes, because you got to remember, you're going to burn through the thinner stuff faster
Yep.
than the back stuff. So you might have to
Gun
change
angle
your
it.
gun angle a little bit,
And
which
I
is
think
a
it's an
big
important
problem.
thing. We definitely want to dive into technique a little bit on this as well. So we did have a question coming in asking where I got the metal thickness gauge. This one happens to be from Miller, directly from Miller. So it came with our 255 when we picked this up. It was right in the owner's manual. But if you go down to your local welding supply store, if you go to if you bought from Miller,
Well,
or
Miller,
Lincoln
Miller
or
has an Amazon
whomever,
page. Like
Yeah.
I've bought for my shield and stuff. I just go online, I order it and stuff like that. Miller actually has a page, so I'm sure you could probably. I haven't looked, but I'm sure you could probably find that on there.
Or again,
Miller
if you-
Gap Gauge and Amazon.
Or go to your welder
Supply.
supplier and say like, hey, I'm a good customer. Like,
Yeah, give me one
You got
of
one
those.
of
Yeah.
these?
And this one, like, it's got a little keychain on it. You put your keys on it for the shop or whatever, or maybe your toolbox or whatever. Some of it, like, there's round ones that are a little bit more heavy duty, a little bit more industrial. That you're not going to need all the different thickness on there, but it's good for steel. And this one's actually got electrode wire diameter too, so 024.
That's to check it real
030,
quick.
035. So if you don't know what
Yep.
you got, in there,
Well,
put
you know,
that
you got the
on.
wire sitting there, and let's say it just doesn't. Sometimes it takes you a second or two to look at the wire, or the sticker is not really on there great. Someone grabs it, they rip off the sticker, and it's like, oh crap, what size
What
is
is
this
it?
wire? Just grab that real quick and
Yep.
check it.
Yep.
Yep.
All right, so let's look at our first coupon here. So now this one, these welds, this was made on 22 gauge material, okay? And obviously you can see here we've got some pretty significant issues, right?
Did you do those?
Yeah, I have made some bad welds too,
I
right?
think your setting on the first one might be a little off.
It was plastic repair yesterday, and now it's welding.
Well, now you can rivet it.
Well, exactly.
Now you can rivet it. Now
you got a hole punch for the
made
rivet, yeah.
A very large rivet, but you made a rivet hole now.
I was going to make a Mig Brazing slot weld.
I see what that looks like. I'm getting you a
sorry,
drill
Avery.
bit and a grinder for Christmas.
All right, so this one, I use the auto set on this Miller-Matic 255 here, but I had it set for 1/8" steel. Now, 1/8" steel compared to so 1/8 is 0.125 and 22 is 0.023. So there's a pretty big difference between
Big
the
difference,
two. So
yeah.
as soon as you squeeze the trigger on this one,
Boom.
it blew a hole in it. Like it wasn't even thinking about.
So you
like,
made it a plasma arc cutter,
I made a
basically.
plasma arc cutter, right? Exactly. So expensive plasma arc
Yes.
cutter, right? Now this one, this was made with the 18 gauge setting, just in the auto set, no fine tuning, and then this one was made with the 22 gauge on it. So this one here, from a profile standpoint, is a little bit flatter, a little bit hotter, so it kind of got in there a little bit quicker. The 22 gauge setting, a little bit higher. Penetration on the 18 and 22 isn't bad. I mean, I've got some decent penetration on both of those. So realistically, again, I want to be at the 22 gauge setting, but if again, based on my speed and my technique, I can potentially get by with the 18 on this one. But I think it's just it's important for it's making sure you got the right settings. That's kind of where I wanted to go. And the one thing with these the charts inside the machine that I have troubles with is I get lost. Like I start, okay, get this wire, and as I move through a chart, next thing I know, like that doesn't seem right. Like this seems like the wrong setting, and I go back and maybe I was on flux core, or maybe I was looking at the 22 gauge chart of 035 chart. So it's paying attention and reading and interpreting and knowing where is a great place. But like I said, it shouldn't have been an issue on this auto set machine unless, again, I set up for the 8th.
You put it the wrong
Also,
thing.
Yep.
shops have to realize that Miller makes welders for, or any welding company makes welders for
Not just
industrial
cars.
stuff,
Not
for
just cars, yeah.
And they usually come DC positive. And if you look inside the machine, it'll show you that you got to switch the,
Reverse.
let's say the red and the black wire to go DC negative.
Yep.
If you just open it up, you put it together, and you go to weld, you don't have an equipment guy that comes in to do it, and you're going to have, you're just going to put it together yourself, you buy it. The big issue comes down is that you're going to start this thing up, and as soon as you start it up, it's literally going to become a plasma arc cutter on this thin material. No matter, you could be down at the lowest settings, and it's still going to just zap through stuff, and the wire's going to burn back into your tip and stuff because it's made for like this frame machine welding.
Yep.
That's what it's designed for.
Flux core,
Right.
yeah.
So now you got to switch it. That's all you got to do, and then all of a sudden, all the settings and everything work better. So just keep that in
And you
mind.
should only have to do that once because you're not
Only
gonna be
once,
going
yeah.
back
You're never
to
going to go back.
DC.
But
Yeah.
if you buy from a company that has a tool supply that's going to deliver it and put it together for you, great. If you buy a Miller, Hobart, or you buy something online that gets delivered, you check that first because you're going to go and maybe not practice and go right to the car, and you could have an issue.
Yeah, and getting really familiar with this, if you get a new welder, spend some time with the chart so you don't wind up like getting lost, right?
Yep.
And Miller has
Know
some
it.
great videos
Very,
online of
yeah.
just how to use their welders. You go online, either YouTube or their page, and they got a whole weld theory thing you can watch, and they even got a little online testing thing you could do just for yourself. But they have the videos on how to set this, how to set that. If you get birds nesting, how to take apart the spools and the drive rolls and how to put back together. So that's just remember that.
Yeah, so two things with that. One, Miller's recently released a collision-specific YouTube page. I should have looked up beforehand. My apologies, Joe. So I think it's Blue Collision. Maybe the name it. So do a search for Miller collision. There's a lot of videos on there, including some collision hub videos. So thanks to Joe for that, and hopefully this one will end up there in the not-too-distant future as well. So thanks to them. The QR code piece of it, or the maintenance of it, we've been talking about, and we're going to work with Sled on this so that we've got some QR codes we can put on there. Take your phone, zap, and it'll show you a video on how to change the driver, how to change the electrode tips, how to change the electrode wire. But knowing what you got in there and making sure that you're watching those videos so you're doing it properly is important. And we're going to talk a little bit more this afternoon about the Collision Hub OEM Welding Validation Program.
Right.
And we'll talk a little bit about the drive rolls and a little bit more of the maintenance and some of the courses that are around with that as well. So, all right, so I did want to make one more. So what I did with this, I kept that on the 18th, the eighth of an inch, or the eighth inch thickness machine, just to see if I could breeze through this thing with this 22 gauge. And this is kind of the result of that. So I had to go super fast. I've got like a little bit of penetration here and there, but I had to go fast. I missed a joint a bunch of times. I got some porosity
you were
in
rushing.
there because I was rushing. But again, this is something that we see on
We
cars
see it,
from
yeah,
time to time,
yeah.
right? And this is not a good weld. Clearly not a good weld.
No.
And this was a setting issue and a technique issue all the way.
Mm-hmm.
And had I adjusted the settings to be proper, I might have had a much better weld on it.
Well, to
Well, and-
compensate
and-
for the overheating of it or the higher setting, you had to run faster,
went
which
fast.
just makes you very, very sloppy
Yep.
and has you dipping in and out, and that's why you missed a bunch of times.
Yep.
You know, and the one thing about this is, so we got the thickness,
Yep.
and we got the, so we, you know, we've got the wire size and the thickness, but the one thing we also have to pay attention to is what kind of steel is it too?
Sure.
It's high strength, mild, you know, whatever it is. And then, so not to bash you here, but none of these would be test welds for any car you'd ever repair. This
Right.
is just understanding technique, you know, and all that. Now, you might use this as a test weld
Correct.
for the car, but these right here, this is just practice getting
is getting
technique
tuned
down
in,
and all
yeah.
that, yeah.
Yeah, the iCar style coupons that you can buy at any welding supply, well, not welding supply, but metal supply company. You can get them cut whichever size, or some iCar instructor left a bunch over there when you took a test.
Yep.
Those are good for, I'm just going to practice to get used to the machine, get
Yep.
my settings. When you're ready, you need to cut material from a vehicle and practice the welds on the same type, thickness, material that you're welding on the car. In some cases, I think I brought up in another show, you might have to buy a used section of a B-pillar and cut it up 30, 40, 50 times to have some of that extra material. Because if I'm replacing the outer panel and I'm welding through an ultra high strength steel middle panel and a high strength steel inside panel where the trim panel goes, and I'm putting a mild steel panel on the outside, how do I duplicate that in the shop?
Yeah.
You know, oh, I got this Mercedes-Benz B-pillar, yeah, but I'm doing a GM right now,
Right.
so I need to have the same. So you might have to buy a couple of used pieces.
And the thing about that too is, you can't. If I want to source some DP600, like good luck, right? That stuff comes in rolls,
Yeah.
right? It goes to the vehicle manufacturer. We had done a program with the Auto Steel Partnership several years ago. We were trying to do some test welds. Like the OEs couldn't get like smaller coupons. You had to buy like, you know, a massive roll.
Gross
'cause
lot.
Exactly.
Yeah.
So you can't buy the material in coupon form for DP600,
Yeah, no.
1500. So so.
You
these
probably
again-
could someplace, but it'd be very, very expensive.
Yeah, so-
and
so
you
a lot
probably
of
have
times-
to buy like 500 sheets of it.
Right.
So the pieces you take off a
you can buy
car,
the
if you're
car.
gonna
Yeah.
if you're gonna chunk a rail off a car and put a new rail in,
Save it.
figure out what it's made out of, and then label it and cut it up into pieces
Yep.
for later.
Yep. And again, we're talking a little bit about the practice welds and the materials and where to get that this afternoon. So let's continue with the heat a little bit. I want to talk about high strength steel and ultra high strength steel because we're heading that direction a little bit. So when it comes to conventional GMA, MAG welding, when it comes to high strength steel and ultra high strength steel, we got some vehicle makers that allow some high strength steel welding. Other vehicle makers will say no,
Nope.
it's got to be spot welding only, or in the case of Honda, we've got some specific electrode wire, which we're going to talk about in a little while. Why can't I use this on high or ultra high strength steel?
It's based on how the heat now changes. I don't want to say heat effect, but because you get in the heat effect zone for the heating area. But yes, the heat effect zone and the heat applied to it is no different than you watch the History Channel and there's a guy with a big piece of metal stuck into a fire pit and he's hammering on a rock and then he sticks it back in there and then
Forged in steel.
Forged in steel,
Yep.
okay? And he's forging something. What is he doing? Then you always see the same thing, even on the show. They dip it into something and psh, you see
Yeah.
all the steam come out. Well, that's oil or water or some other mix. And what they're doing is they're actually tempering it or hardening it. Now, yes, something like ultra high strength steel or alloy boron steel is very, very strong, but also more brittle once you play around with it. Because it can only be done once. It can't be bent back and forth. It's the old iCar thing where we stood there with the paper clip.
Yep.
I made everyone do this and it got
Work
hot and it
hard
broke.
and- yep.
And it's getting over work hard. Well, I can do that with heat also. I can keep heating it and cooling it, heating it, cooling it, and literally I could just go like this and it'll break
Well,
instantaneously.
anytime you heat metal at all,
you're changing the
it
molecular
changes.
structure.
It changes.
Yeah.
Period.
Mild steel's a lot more forgiving because you make it a little bit stronger, but it doesn't become that much
But it
more
still
brittle.
changes.
So-
High strength steel, same thing. Ultra high strength steel or advanced high strength steel, forget it. That's why there's very, very few companies that allow certain sectioning, with it, and that's why a lot of times it's resistance welds unless some company calls out something different.
Yep.
Yep. Yeah, because we got great penetration and good looking weld, but if that weld area around it is garbage,
You can
then
actually take a
that's not gonna work.
hammer. We did some testing. I remember Jerry Goodson years ago. We were just welding on a rear body panel, I think of an XC90, which is boron alloy steel, and we just kept welding, stuff on it, and then I just started beating it with a hammer, and it started to crack. Which you normally couldn't do that to this board, but I crystallized it so much and raised the strength so much it became very, very brittle.
Right.
Now, there is one OE, and we've got it on that we want to talk about, that actually says the opposite of like everybody else. Nissan says for 980 MPa and above, no spot welding. They want mag welding. Now, I don't know the reason behind it. That is something that we definitely want to work with Nissan to get.
Yeah, I'd love to hear an
Now,
answer.
the one thought, it could be a translation issue.
Right.
The other thought would be, it could be like the old spot. Remember the old MIG spot welds where you just
Right.
stand there and just
Yep.
until it did this,
Yep.
right, on the top
Right.
coupon?
And that might be a translation
That
issue.
might be what there is. So we'll be reaching out to Nissan at some point to see if we can get some clarification on that. We'll probably cover it in the Technician 20 group, and send them maybe a pickup tech broadcast.
And
at some
especially
point.
since we see Honda put out such an elaborate chart on their welds and steel and aluminum, on steel, the different materials, and it's very similar to how Nissan cars are built in the same way. And I'm like, it's the same strength material, so I'm wondering why. I'm thinking it's a translation issue.
Yep. Okay.
But that is what it says, right?
Yep.
So
Right.
what are we going to do?
So let's talk about plug welds for just a little bit before we move on to electrode wire and beyond and technique and stuff. But so what we've got
The
here
hardest
is-
weld to make.
We've got a couple of different plug weld samples here. Now we've got an OE. Now some OEs are going to have, most OEs are going to have a recommendation for plug weld size based on, again, the material thickness and type. We may be doing a 6mm plug weld. We may have an 8mm plug weld. There's some 10mm examples out there as well. We're looking at a Hyundai chart right here, and based on the material thickness or the governing metal thickness, depending on which OE, they're going to have different hole recommendations for plug weld size. What's that? I don't know what he's saying.
No.
Okay.
Okay.
So what I've got here is we've got some 6mm and some 8mm plug welds. So these are 8mm plug weld holes. So the top coupon had 8mm hole in them.
Right.
Here he's going to come in. Oh, there we go. Sorry. There we go. That's what he meant.
Oh, okay. I thought I was stealing second. That's all I Live
Avery,
shows.
you're a movie star now.
So we've got, now this is also, these are made on 18 gauge coupons, which would make sense to have a little bit larger hole, an 8mm plug weld
Right.
hole on it. So these are all pretty good. What do you think of those ones? Those ones okay? Since you guys have been hassling me about everything else, are those okay?
Well, like anything else, you got to take a look.
Most of them. There's two of them that are good.
I'm going to say, well, listen, this one would pass. It just, you stayed there a little long, and I'm going to try and rotate this just a little bit, see if we can
Kristen
get that
made that
divot.
one.
Oh, Kristen made that one, okay. That's actually very good, Kristen. Normally the weld's over here, and the hole's still there. But these are very good. And then we have the back side, which there should be a ripple to a certain extent.
Those will tear.
And I believe that all of them will tear. This one's just a little ugly, and a little high, and misshapen a little bit.
Yep.
And these two are very, very good in that fashion there.
Good. Thanks, Larry. All
Get a
right.
pass from Larry.
So what I've got here, so I've got a variety of 6mm plug welds here, and I did, again, these were made intentionally the way we made them. So this particular one, let's flip it up this way so I can see those. My letters are upside down, except for
Yes.
the X was right, and the O was right, but everything else is upside down. So this one right here, this 6mm plug weld right here, I made by just putting the electrode wire pretty much right in the middle of the weld. I squeezed the trigger. I moved very little bit around that. It's a small weld, right? 6mm is not very big. So I just made that one. I got good penetration. I got a decent sized face sight on it. So I'd be pretty content with that. If I was going to make a bunch of plug welds on a vehicle that required 6mm, I'd be comfortable with that one. This one, I started on the outside and worked my way in about the same speed, but I had to go around a little bit more because I started on the outside of the weld. I got some decent penetration on the backside here. One thing, if you start on the outside, especially on a smaller weld, what can happen is that electrode wire can fill up that hole before you get into that bottom coupon. So if you're going to do, it works fine on an 8mm plug weld.
Bigger ones.
But
yeah.
if a smaller one, when I'm going around that hole, if the material starts to flow over that edge before I get to the center, I could have a high weld, which I have a high weld here, with no penetration. Now this one's got a little bit of penetration. I wouldn't be super happy with it, but that's one thing that can happen if I start on the outside of a 6mm. So my preferred style personally, again, this is my technique and everything, right in the middle, zzz, and then a real quick circle around.
That way you
Other
guarantee
issue-
you're going to get penetration.
Yeah.
The other issue you need to look at is this is the thinner
This is 22
coupons.
gauge.
Right, this is thinner material, and I'm probably going to wind up betting, especially on this other one where you start on the outside and rotate it to the middle, and you got a high weld. I'm going to go with you probably got 030 wire in there.
There's old 30 wire in there, correct? Yep.
So this is the issue that a lot of shops don't understand. When you're welding outer body panels and you're welding most unirails on unibody cars, you're welding with 0.6 millimeter
Yep,
or
024.
024, 025 wire, 2325, 2425.
Yep.
It's all 0.6 millimeter. That's what you should be welding with. The machine will work better at that lower grade with that thinner material. Had you had 0.6 millimeter or 024, this would probably not be as high and would have came out a lot smoother, and you'd be happy, probably a lot happier with both the welds, not just the one weld. And that's where the shops kind of get misled. 030, 035 are 220 machines that are for full frame vehicles.
Doesn't sound like much. It's a big wire, though.
It's a huge wire. Trying to weld 030 wire on thinner material
It's tough.
is difficult to get a good weld, and that's why a lot of these guys have big, huge beads or high welds, and they got to grind, and once again, grinding or dressing adds more heat to it. So that's what they got to realize. So that's a good point to show there. That second weld that he's not a little unhappy because it's high because it is 0.6. Well, it's a smaller hole. It's thinner material. You should have been using, even on the other one, you should have been using a thinner wire. But you know, that's why it comes in handy to show this.
This one, same thing. I started on the outside, got a little bit high on this one as well. This one, I went a bunch of times around. And again, I've got the penetration. It doesn't look bad, but it's super high. It would require quite a bit of dressing.
Well,
and
and the other
this
thing-
one, I intentionally missed a joint on that one because, again, we see that. Whether it's a 6 millimeter or an 8 millimeter, or especially 10 millimeter.
Sometimes it's lighting, your eyesight.
Well, it's hard, right? If you've got a good angle on that, you're trying to get around that plug weld, like it's hard to like see around that thing the whole time.
And you
that
get what's called the
happens.
half moon.
Exactly, just what we got here.
Yep.
If my torch is positioned over here, my body's positioned over here, that's what's going to happen. Because it's too dark, I can't see where I'm at, and again, it's a small hole, and I assumed, oh, I got it, and clearly.
So let me go back to this real quick. So, so if you look at the heat effect zones, which is the amount of heat that's going radiating out from each of these, and you said you went around and around on this one.
Yep.
You notice how big the heat effect zone is around this one versus all the other ones.
You see that, Avery? I don't know if you can see this. So see how big this heat effect zone. This is what? That's an inch. Diameter almost?
Yeah, and you're actually destroying, you're throwing heat into it, which starts to change the molecular structure of it. So you want to get in and out of your welds as appropriate to get your penetration. Don't just keep going in, around and around.
Yep.
Another thing about that big fat weld at the bottom there, probably on the I-cart test, which is where the 6 millimeter hole came from, more than likely you'll look at it and go, oh, this is a good weld. It might be a little high, but let's break it. And the back piece might just fall off because you actually had so much heat, you never directed it to the back panel. You only caught the front panel, and as you welded, you literally welded the round circle edge, and then the rest of it just overflapped and never grabbed the back. And that's sometimes a false positive, I guess you would say. It's like, oh, positively, it looks good. And then you go and destructively test it, and it's like, ooh, this is no good. I did something wrong here because you didn't point it at the back joint first.
And we're going to talk about all that this afternoon. Destroying and what happens.
Yes.
Yeah.
Okay, so let's continue with technique a little bit before we jump into electrode wire and move on. So this is a weld. These weld joints are ones that Mark recommended. I thought was a great idea. The joint, the recommendation.
I know.
So what we've got here is, on this coupon sits below this coupon, and the arrows on here represent where the torch angle essentially that I used. This one has the coupon underneath and this coupon on top. So this coupon is the top coupon on both. But you'll notice this one, I forced the weld into the joint. This one, I forced it over the top. And like the only time it would hit the bottom coupon is if I happen to break off enough of the top coupon or melt enough of the top coupon to get into it. So you can see this one's like, it's a fairly smooth continuous bead. This one is erratic as can be because the wire's going out and it's missing and it's just diving over the top.
Can't find it.
Well, because you have, regardless if you had thicker and thinner here, the fact is that, like, yes, you're feathering over the top of it.
It came down to technique. So all my settings are great, the wire's good, I got all that dialed in, but because of my technique now, I made these essentially the same speed, Same thickness. You know, I didn't let it cool. As you can see, it's a little bit warped in there in between welds, other than to clamp it up there. But the only variable was my gun angle on this one, and again, that's why it's important to be pointing it. And same thing with those plug welds, right? I want to make sure I'm moving that torch around.
It's a lot of dexterity
it's not necessarily at 90. It's going to be. I'm going to
kind of.
You want to be perpendicular to it on a plug weld.
Yep.
And stay in your weld, and that's where you're punching there.
So technique's important as well. So far, the only things that matter right now so far are heat, technique, thickness, electrode wire.
Other than that, nothing matters. Right?
We haven't really talked much about the machine. After the settings are done, the rest is all on the tech.
Yeah.
Which I brought up earlier about it. It's all on the tech, and you can easily, just by the gun angle, the gun angle, same settings, you can make a bad weld out of something just because of the way you're running the bead.
Yep. All right, so let's talk a little bit about electrode wire. Yep, I've got them. Question on steel. So using 030 for outer panel works, but 025 or 026 will make a nice weld. Yeah, again, Matt, we want to make sure that we're choosing the electrode wire that's appropriate for the thickness, and start with those OE guidelines, which is a good segue right into our electrode wire selection that we've got here. So this particular vehicle manufacturer is calling for ER70S6. We saw earlier the previous screen that we had some plug weld diameter recommendations for the plug weld size. You're also going to see a lot of.
And also based on the flange too. Sometimes, like they call for a 6 millimeter. It's probably a thinner material and not a wide flange. 8 millimeters can be a wider flange and thicker material.
And so the OEs are going to have, again, the thickness. They're going to have a recommendation for the diameter of electrode wire. And again, if you don't have that, then again, start practice welds is going to be your best or making practice welds. Referring to the selection guide you've got there, but yeah, essentially, thinner material, you're going to want that 023, 024. We start getting a little bit. 18 gauge for me, I think, would probably kind of be the cutoff. Like, I wouldn't go above 18 gauge with 023 or 024. I'd probably want to have 030 in there. Conversely, going back the other way, I won't want to have like 035.
Well, Miller actually has a chart on their website, and I think it's actually in your manual, not in the flap, but in your manual, and it shows you the settings on the machine and the wire size. And I think it comes from AWS, but they give you a color chart, and it tells you if you're welding this type material, this gauge material, or millimeter, it tells you use this wire.
This is where you start,
if you're using this thickness material, use this wire. There's a slight overlap as they go down the list. So like there's a point, like you said, I'm going to go from an 024 where the machine's cranked up a lot, and I'm going to have to go to 030. So you want to, to optimize the machine, any machine, you always want to try and stick in the middle range. And that's why they try and show that to you.
The chart in there probably is not going to have 24 gauge selection with 035. They're not. It's not even going to be on the chart probably.
It'd be 045 then.
So Matt, start with the OEM. And again, find the information from them, and then defer to your equipment that's going to be on there as far as their recommendations for it. So, okay, so let's talk about electrode wire a little bit more. So, ER70S6, that 70 is kind of ER70S6 is kind of a staple of electrode wire.
Electro rod, 70,000 pounds per square inch, solid core wire, and then the dash will now add to you what chemical makeup to try and help you with the weld. Dash 6 has a lot of manganese in it. That's why you get a nice, if you lay out a really nice bead looking thing, sometimes you get this, it looks almost like caramel melted around the outside
edge. It's got some silicone in there too.
Yeah, there's a little bit of silicone in there and some different percentages. Listen, there's manganese and silicone in Dash 3. It's just there's more of a percentage of manganese in 6. I mean, some of the ornamental guys, the guys who make crafts and stuff, will use Dash 7 wire. A little more expensive, and you can assist in laying out a little bit flatter, prettier of a bead.
And it's pretty similar to 6.
Collision.
Yeah, and one of the things that we found with Vico in some shops is that we open up, look at the welders, and they have this stuff in there without a dash. It's called Easy Grind, which is really easy to grind. The problem is it's got the wrong strength. It's not for automotive. So, but a lot of techs go, oh, I like that stuff because it's easy to grind. Yeah, because it's really soft and really doesn't hold the car together.
But if you welded better, you wouldn't need to grind so much.
So just something to notice that or you got to have -6 in there, -7 or 3 or whatever it says.
And the manufacturer will call it out. I mean, you also got to look at, they'll sometimes require certain different gases, which I know can be an impossibility to get.
80-20 versus
Yeah, we even
75-25.
65-35 at one point. They actually stopped. I think Toyota had at one time 65-35. And they're like, it's impossible to get.
Yeah.
It's very expensive because they have to mix it
If you
differently.
bring it from Japan.
Yeah.
All right, so the chart that we've got up is a Honda recommendation. Now, most OEs, and that's a big statement, but most OEs, if they're going to have an electrode wire requirement, it's going to be fairly stable, right? It's going to be ER70S6 or ER70S3, or maybe 3 if it's a thicker material, 6 if it's a thinner material. Honda's a little bit different. So Honda allows you to use conventional ER70S6 up to material that's 440 MPa. Now, if you get above 440 MPa, they have from above 440 up to, was it 900 the cutoff, or 1500? But regardless, they have a cutoff, and I think it's 900, isn't it, Larry? So from 440 to 900, they have a special high-strength steel electrode wire that they require.
Bowler
It's now. What was the old one? The old one was a Bosch wire.
I think it was a Bosch wire. Yeah, wire.
You can get it. I know Pro Spot was selling it for a while. There's some other equipment manufacturers.
When it first came out, it was really hard to get.
Literally, yeah. But now it seems easier. And if you literally go on their repair website, for Honda, there's actually a listing of where you can get this stuff. And they actually have an article that came out that they update every month. And it'll usually have, they change suppliers. Yeah. And they give you the website, the phone number and stuff so you can get it, and the part number too.
And it was really expensive too.
Yeah, it was a little more pricey.
Yeah.
Yeah, so I think they're saying up to Bosch. Yeah, the Bosch wire is still on there.
Yes.
030 diameter, welding joints, high strength steel, 590 and higher. So they've got a gap in their material from 440 to 590, so that's the jump that they made. So you're not going to find 460 or 480 or DP 500 even. So it's going to be 440 and lower is conventional ER76. Above that, starting at 590. We'll have to get confirmation. We'll follow that up when we come back in the practice weld show. So either up to 900 or 1500. I think that it may be to 900, and then it just goes 900 to 1500. So that's.
It's more of the non-repairable stuff.
Yep.
Where you're just going to replace panels or components
put a new one on.
Welding it, yeah.
And the other thing we want to look up too, that this is you told me to do this, and I failed you, Larry.
Okay.
I feel shame.
I don't remember.
Was around, can I use this bowler wire on anything?
Yep.
I believe it's in the
can,
article, and I got to double check it. And
but
we read some other things. The price doesn't make sense to use the bowler wire on. You have to use it on the high-end stuff, but if you're welding on the lower grade stuff, hey, yeah, you could still use it. It just probably isn't, smart to use it because it is a little more expensive. So let's keep the expensive wire for the side stuff.
Yeah, a lot of shops back in the day when this first came out, they said, I'll just buy the Honda stuff and I'll just use it on everything.
No.
But,
Yeah. It's just,
That's $500
that's
a spool
what
or
they did,
whatever
yeah.
for the small spool.
It's crazy.
Okay, so let's move on. We're running a little bit behind here. So let's talk about dressing welds a little bit before we move into spot welding and Mig Brazing.
1,000 in blue on the side.
Oh, okay.
Yeah.
That's the technical term for grinding.
Got it.
Sounds a little more professional.
So this is a question that we still get, like, hey, if I don't think I should dress my welds because I'm reducing the strength of the weld. Well, if you're not cutting into the bottom, into the coupons that you welded together, it's okay. Now, iCar did a test and wrote an article around, and there's a video around this too. But they'll show you where they made 2 different welds. One was undressed and one was dressed, but not getting into the bottom layers. And essentially, they tore it the same strength. So if you are going to weld dress, and again, if it's hidden, right, if it's an enclosed area,
covered by interior trim panels or whatever.
Just sand it with some sort of roll lock disc that doesn't remove material, just cleans it up. Even like one of the brushes, because I'm just looking to clean the stuff off. And then you could, so paint adheres to it so it's clean. Outer panels or something like that, you see, you have to be very, very careful and stick with a grinding stone is the best thing to use. Not a cutoff wheel, but a grinding stone, a cutoff wheel. And just grind down the steel, the weld that's there. get it as close as you can, and then sand over the top of it with some other lighter grade paper, 80 or 100. You would still like literally have like just a tiny
bit
little height on it, so that you still have some of the weld that's left over, and then you can do your filler or something like that.
Well, the strength of it, especially on a plug weld, is in the penetration of the
the
metal.
where the weld
So if you dig into either side of that, you've actually destroyed the
weakening it,
steel
yes.
and you weakened it. Yeah.
Yep.
And keep in mind that the panel shouldn't get super hot while you're grinding either. Be careful with that, because you sanded it to prep it to be welded. You welded it. Now I'm grinding it. I'm adding more and more heat to this each time I do it. Even cutting it added heat to the panel. So you're changing the molecular structure of the you're work hardening it in a way by heating it, tempering it, I should say.
Yep. So, yeah, so go check that article out if you've got questions on it. I think it's a great article. Got a great video, really demonstrates.
Did you write it?
I did not write it.
Okay,
no,
got it.
I did not. I may have suggested we write
Got it. Okay.
Yeah. All right, so let's jump to spot welding. Now, we don't have a spot welder here today. We are, our spot welder got picked up. We're waiting on our new one, so hopefully that comes through one of these days. But let's talk about some of the factors of spot welding. Before we even talk about the equipment, let's talk about the shop power, because I know that's an issue. So give us the elevator pitch about why having the proper power in your facility is important.
You have to have a 3-phase power for it. When you do run the wire through the shop, once again, code in most areas is, the bare minimum passing.
Right.
So the problem is a lot of times they want to run 6-gauge wire instead of 4-gauge.
And it's not enough.
And listen, you can just Google it. We're not going to explain it here and do an electrical class, but every 6 inches is a drop off in power. So if I, bring a line to this wall behind us over here, which is about maybe 15 feet away, and then I'm going to run it all the way around, and people have seen the scan of this place before. I'm going to run it all the way down over there, which is almost 200 feet, and I'm running 6-gauge. You know how much drop off in power I'm going to have? And that's when you weld and you hear the brrr. It's literally shaking the wire.
So a 100-foot extension cord's not a good idea.
Unless it's 4-gauge.
Right, exactly.
Or 2-gauge.
Or 2-gauge, yeah.
Which would get very, very heavy.
Right.
A 100-foot cord at 2-gauge, you and me are going to have to carry it, and we're going to struggle with it. And then also follow the manufacturer of the equipment. Most of them, from what I've read, once again, read the manufacturer of the equipment, is usually going to be a 60 amp break and not a 40 amp break. Otherwise, every time you're going to go weld with the 6-gauge wire in the wall, with the 100-foot 6-gauge cord and the 40 amp breaker, you're going to go bzzz, bing,
Clip. Yep.
well, the lights out.
Yeah.
And you're going to keep going back and forth with that, and it's just become more and more annoying. So you're going to have to spend a little extra money to get it the right way. And if you're in a rural area where, 3 phases, 60 feet off your property, and it's 25, 30 grand to get it into your shop, you're going to need to get it into your shop because you're way overpaying for electricity on everything else running in the shop. And on top of that, not many manufacturers allow for these battery-operated resistance welders. And
Do any?
not that I can really think
there
of the
was
top
a-
of my head.
I can't think of anyone
I
either.
can't think of any.
And that's a question that
I mean,
comes
it's probably
up.
go okay for like, restorations. You're in a restoration shop, knock yourself out.
So
You're
are
just
the
going to
hand
keep
ones.
charging it.
So are
Yeah.
the hand ones,
Oh,
right?
no, yeah, I wouldn't use the hand ones.
Yeah, so when you walk through that, just spend 30 seconds on, okay, so I got this battery, why can't I use it, and why don't the OEMs recommend it?
The best I can tell you is probably it didn't pass the testing for the amount of welds. I mean, I know from talking one time with Pro Spot and even some guys from Carolina, they literally had to come in and they had like a 10-foot long, and they had to keep welding and welding and welding and welding and welding and just blast, and this thing's getting super hot. But they wanted to see the machine run. How well does it run? What's the duty cycle on it? How hot is it? How distorted does the metal get? So there's probably a bunch of parameters of 10 welds through super thick, and then I've even done it at SEMA for a couple of companies. You just keep piling metal on top of metal, and literally I got like a stack of metal you're never going to weld in a car, but it's still welding through it.
Yeah.
And then I ripped it apart, and you could see it pulled out the. So there's a lot of testing that goes through. I guess the machines aren't passing the testing.
Yeah.
I don't know what these engineers are looking for at the OEM or who's involved.
Yeah, well, and that's one of the questions that comes up often is, I'm in the middle of somewhere that I don't got 3-phase power, I don't have enough, I'll just buy one of those. Yeah. And then they're really disappointed when they go to apply for an OEM certification program and they go, well, sorry, that doesn't pass.
Right, and I just bought this machine that's
Exactly.
fairly expensive. It's not like, these machines are $20,000, $25,000, and the battery-operated one is $1,000. No, it's close to that same
close to that,
price.
yeah.
It's expensive.
Yep.
All right, so cleanliness and practice welds. I think we should talk about the practice welds. We'll move that to this afternoon and try to catch up here a little
Yep.
bit.
Well, yeah, I mean, we're going to talk about, well, once again, we just go, make sure everything's clean, wiped off,
Yep.
sanded, and always do your practice welds with the same arm setup and stuff like that, bonding adhesive, and we're going to go into that later about that. We're just talking about it.
Yep. So, and this kind of points, and this is a good segue into our clean tips part of it. So the clean tips is paramount, right, to a good weld. So it doesn't matter if
Everything's
everything
gotta be
else is
clean.
great.
Yeah.
If I got ugly tips, if I've
Burnt
got mushroom
tips.
tips, if I got burnt up tips.
Metal particles stuck in the copper tips, that happens.
What's going to happen if I have that metal material?
It's not going to make a proper weld. Some of the machines still now will make a weld, and you think it's good. Some machines will not make a weld unless all the parameters in this machine, and those are the more expensive, smarter ones, and even then they can still make a bad weld. So it's important to realize that. Some of the older machines, you can trick them out and make them weld with crappy tips, and it makes some sort of mark, makes the metal stick together, but destructive testing, sometimes it just pulls apart. There's no tear out.
part of the issue is, you know, if you look at the tip, and I know we've got a slide coming on this,
Yeah,
but some of the tips, you know, it's going to make a 6mm weld or a 7 or whatever, you know, whatever the specification is. But then when you mushroom it out, now it's 10. So it looks like a nice big weld.
Yeah.
The problem is we just don't have the penetration.
Let's jump to that because for spot welding, because I think the power stuff has been talked about for a long time. That information is readily available. But I think that the mushrooming part of it is something that gets overlooked. That technicians just keep going. And again, you know, we got our user Emmerich. I might clean that up every once in a while, so my tips might look good because I keep cleaning them.
As long as you keep them shiny, they can't misform. They're supposed to be like an egg roundy type of, you know, end piece to it. And it's not supposed to be flat and round like the bottom of the back end of a chisel or a center punch that you hit with a hammer.
Yep.
It's not supposed to look like
Well, that's
that.
where the guys, they walk up with their 80 grit on a grinder and just grind it off.
Yeah, no, you don't
It
do
doesn't
that
work.
either. There's
Well,
only a
shops do it,
sharpener
though.
that they have, and
Yep.
when you sharpen, it should be like zip, 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 and that's it. Not zzzz, like you sharpen a pencil back in high school.
Yep.
You know, you can't sit there for 20 minutes trying to sand this
Well,
thing
and the
back
other
into
thing
shape.
is that a lot of technicians, they'll get a hold of it, and they might start with the clean tips. They might clean them up real quick, and then they weld about 80 welds.
That's great.
But if they're not cleaning in between, you know, paying attention
Well,
to their
sometimes
tips.
it's going to get stuck, and you're going to have to and you know, break it off the metal. Now you got metal particles on
Right.
there.
That might tell you maybe to do something.
Yeah, you might want to do
Maybe you have to
something.
do something, yeah.
So I want to read this because I think this is really a key part of it, and then we're going to show you a chart after this. But this is from the Resistance Welding Manufacturers Association. The size and shape of the face of the electrode is related to current density. It is the current density that must be maintained constant in order to make welds of consistent quality. Electrode wear contributes dramatically, that's a big word, right? Dramatically to current density. An increase in electrode diameter of about 25%, which is pretty small on a 6mm electrode tip,
Yes.
right?
Now you're at 8 millimeters.
Can reduce the current density by about 40%. Even though the control is maintaining the current constant, the weld nugget strength and size will be reduced. Even though the current remains constant, the current density reduces, reducing weld quality.
So I remember my teacher in 7th grade, we were talking about geometry.
Yeah.
And there's this thing called the circle, and the area of a circle.
Yep.
And you figure out the area of the circle with this cool thing called pi.
Hi.
Yeah. So
I like apple
as
pie.
you
too.
as you move out 2 millimeters, it doesn't just go a little bit bigger, 20% bigger. It goes like 80% bigger, and they're talking about a 40% reduction in a 2 millimeter increase. So it's not just a little bit less; it's a lot less.
And most of that with the bad tips or the wider tips, most of the look of the weld is from the pressure. You know, the pressure joint itself actually making a little bit of an indentation. It's not a weld indentation. It's a compression indentation that basically just sticks together for a second, and there's almost no heat.
So here's what it looks like. So this is also in that same RWMA.
This is a
document.
great
This is
picture
one.
showing
So,
you.
Quarter inch, now these are a little bit bigger, right? So this is a little bit more industrial kind of stuff.
Right.
But here, so a 1/4 inch diameter, 100% of current, 245,000 amps per square inch is what's going through there at full capacity. As I increase, again, exponentially up to a 1/2 inch diameter, now I'm at 25% of what the machine power is set for, and I'm down to 61,200 amps per square inch. So that's a dramatic
huge drop.
issue.
That's
here.
dramatic on thick stuff like this. Imagine going down to, you know, thin metal like this. you know, where you got 15,000 amps going through it, and now all of a sudden you're down at 7,500.
Yep.
Literally, you could just do this and they'd
It'll
fall
apart.
Yep.
Well,
Yeah.
it just did actually.
No, that,
Sorry, Jason.
That's this one.
I know.
that's
I
this
know.
one.
But yeah, this one, I've used this a lot because I think that this is something that, again, just it gets overlooked. And we get complacent as technicians, and we're not the best at maintaining our equipment, and the tips are a key. Once we get the shop power, and we've got this expensive piece of equipment, I've got those tips, and that's kind of what I'm counting on. And if I don't take good care of those tips, I'm going to have problems, and this really points
It's
to
going to make
that.
your job harder.
Yeah, well, and many shops that we've been in, like Texas, back to that, right? But they had the same tips on it 2 years later
Yeah.
that came with the machine.
Yeah.
There's hundreds of cars that aren't fixed right.
With no extra tips laying around
no
anywhere.
extra
And,
tips,
there should
no.
just be a bag of tips
Yep.
that are around, because that tips mean that you have cooling all the way to the tips. If you just have rods in there, it's not cooling to the tips.
Correct.
Yep. All right, now let's jump from spot welding. Let's just talk for a couple minutes about Mig Brazing, because Mig Brazing has become a little bit more popular in the past few years. I think Honda really kind of led the way, you know, so with that 1500 MPa material, areas that you can't reach spot welding tips for, they require Mig Brazing. When a lot of experienced technicians think about Mig Brazing, they think back to like old brazing,
Yeah.
right?
Torch, and I got the
Exactly.
hanger.
And the question that we always get is like, well, how can these things be strong? Is the number one thing. So first of all, we're not adversely affecting the steel as
No.
much. But the thing about Mig Brazing that we get is we're usually dealing with a slot weld, or in the case of Honda, as you can see here, we've got side-by-side kind of plug welds that then Honda makes them in a zigzag pattern.
Zigzag pattern, yeah.
So what you're doing with the Mig Brazing is, although you're not, you know, fusing the metal together, you're using that surface area to get, and capillary action, to get in there and make a strong joint. Not a strong weld, I don't want to say weld, but a strong joint, a Mig Braze joint. That's where you're getting that strength from. And then you've got multiple, you know, Mig Braze joints on like the lower B pillar on the Honda vehicles.
Yeah.
I think they call for 6, 8, 10 Mig Braze joints.
And so your
in those
gapping
areas.
is important. Well, you did a show.
Yeah, we did a
on,
show
on,
on it,
on
yeah.
Mig Brazing, and so your gapping, you can't just have the panels clamped tight because
No.
you got to have a
Yeah,
little bit of a
yeah,
gap.
Just a pinch of a gap.
Explain it, because I think that's, again, that's another important, because we always want to make sure we got good tight fit up,
Yeah,
right? That we're
not with
looking
Mig
Well,
for.
you know,
But
when you
not with
when you
Mig
have a
Brazing.
tight fit up where you can't see light through it, what happens is that you can't get the material through there because it doesn't melt everything. You need just a tiny little space in between there so that you can get the material to get the capillary action. You need it to spit through to the back
Yep.
and kind of spread out a little bit, which works nicely. And you know, Honda with this, Honda's the first company I can think of outside of Mercedes-Benz had it on the old 216. The first time they came out with aluminum steel on the coupe, the S coupe.
Then on the roofs too. Totally.
And they had and we're never going to do this repair procedure. It's the rear floor joist underneath the back seat that you'd have to change if it got walloped in the side, and you had to do slot welds. We never did it. We had the machine. You never did it. But the Europeans were famous for outer panels, welding it to keep the heat down and not have distortion. Honda's the first company that I think launched forward with structural components being this way. And I remember slot welds back in the day, you never made slot welds on anything. Now they have you making slot welds welded on only one portion of it. And then they came out with this thing with these, you know, with the two round holes. This is for structural, ultra high strength steel components to keep the heat down. And once again, the material makeup of this silicone bronze wire, a Mig Brazing wire,
we
has
have right here,
changed. Yeah, over the years and stuff. And even this material here, you know, when you're not using it, take it out of the machine, put it back in a plastic bag, Ziploc bag, keep it away from stuff, cold, dry place, you know.
yeah, I mean that's a lifetime supply for most shops.
Yeah,
For
right.
Yeah.
Now, a couple things about Mig Brazing. You mentioned, you know, the Europeans, Jaguar XF, and they've got some Mig Braze. And the other one, domestic, would be GM on some of the upper rails that are attached to the upper rails attached to the A pillar.
Well, we found
They've
that
got
on
some
the,
Mig Brazing on there
remember
as
we did
well.
the cruise?
Yeah,
And
yeah.
they had silicone bronze, and I was like, and we brought up in that case, Kristen let me put something European in, and it was almost the same repair procedure or the installation procedure as an E-Class Mercedes-Benz, which was hilarious that it was so similar, except they did have slot welds for the rear body panel to the quarter panel.
Yep. We did have a question come in with regard to silicon bronze. Do I need to change the gun liner and tip? So
You should have a dedicated machine for that. I can't stand one machine, and I'm going to keep swapping out gun liners and gun tips or torches, torch assemblies. Have it set up separately for that. Silicone bronze is different than copper steel, which is also different than aluminum wire, and you can't intermix. You're never going to clean the machine good enough, and you're going to have issues with welding. Keep a dedicated machine, and
or a multi-head torch.
Multi-head torch, and I'm a fan of having steel and silicone bronze at least on one machine, and aluminum completely separate. You know, ideally you have a dual head machine that has silicone bronze and let's say 024 on it, and then you have a machine that has 030 and 035. Now everything's set up for that, and then you have your separate aluminum machine. That's it. I don't know why people put an aluminum and a silicone bronze. You're never using the two in the same area.
Well, you're barely using the two anyway.
Right, and you're never using them in the same area because there's no silicone bronze on aluminum.
Right.
You know, so why would I have it?
So like this machine here, but it does require 100% argon shielding, I guess,
Argon,
which is probably why they put it with the aluminum, right? Because they're using the same
Right, so I
gas.
have one tank instead of two.
So
What's
this
the big deal?
particular machine here, so this one here we've got C25 and then we've got 100% argon. And on this one, we have an extra torch. We're just taking the torch out.
Right.
New torch out, replacing the drive rolls, replacing the electrode
it's a different
wire.
machine. And
so it's kind of a different machine within the same machine.
Same machine, right.
Yeah.
But if you're buying a dual machine, and in this case, personally, for a collision repair, I know we have them small because we don't need to waste the money on it. I'd have the big, huge tank of CO2, 75-25 with the CO2,
Small argon.
and the full argon. That tank's good enough. It's going to last you probably the lifetime of your career with welding silicone bronze.
Yep.
Aluminum, you probably need a bigger tank.
So with regard to strength, again, it's again machine settings, heat control, et cetera. But it's when it is capillary action is a big driver, and then again that surface area, and that's where the capillary action comes in. If it's too tight, we can't get the capillary. So we have.
And this takes some practice.
Yeah, absolutely.
Yes, it does.
Because it's different.
It's a different welding process, different working process, like anything else. It's more similar to steel. Aluminum's completely different. Even though you're using a similar looking machine, it's completely different, the welding process.
Well, speaking of aluminum, let's go to that.
Let's finish with aluminum. And,
Aluminium.
We'll let Larry pick up where he left off last night.
Yeah.
And we'll go to lunch.
I was going to say, well,
Hey,
we're going to go out and buy him a TIG welder.
I was trying to help out, and you guys you're very abusive.
Let's just cover a few things on aluminum weld strength, right? Because that's the focus. So what are some things that make a good aluminum weld, and what are some things that make a bad aluminum weld? And then we did have one question coming in about the use of a spool gun. So
never.
So
I'll solve that right off the bat. No, never.
So Larry doesn't like spool guns.
I believe if you look at the older vets when they first came out as aluminum, the Z06 when it first came out, and it was only the Z06. I believe they allowed a spool gun on the program. I think, I'd have to look at the procedure, I think it's since changed. They have newer equipment that they want you to use.
Back when I used to teach the Z06 class, it was a spool gun.
Yeah,
But no.
and the spool gun's great if you want to make, you know, ashtrays and little trinkets and weld stuff together. That's great, but you know, you don't do that with, they're making all sorts of different ashtrays out of car parts.
It's all good.
You want to weld a little box of aluminum stuff together to like put your keys in it. That's great. Use a spool gun. You want to play around? That's great. It's a hobby thing. Do not use it for collision repair.
Why though?
Because you're going to have...
Well, people are going to ask that question, so let's just
you're going to
ask
have...
it.
But first off, it hasn't been approved because it doesn't spit out the wire fast enough. It doesn't have the proper movement of it. And you need... Actually, they have dual drive rolls. Most of these gun heads have two little drive rolls inside, and then they got drive rolls inside the machine. So it's a push-pull type system versus just on the spool gun alone.
We'll have to verify in the OE thing because I don't know, because there may still be some requirements or some allowances for it out there.
Like I said, I'm unsure about the GM program.
I think the biggest challenge that I've had with a spool gun when it comes to it is just the access. Like if I'm trying to get in a tight area, I've got this big thing, which is why just a regular old push-pull kind of feeder works well for that. But let's verify that there are no OEs that allow spool guns. Say there may be some out there. So I don't want to jump to that with a blanket statement until we verify. But I think that's something we can maybe research in between and cover on the practice show again. So
they might allow it.
Yep.
You know, once again, I would never recommend one, but you
Yep.
know.
Yep.
They might allow it.
So so let's jump in. Let's go back to the weld strength. Sorry about
Right.
that. We kind of diverted on that a little bit. But what are some of the things that make a good, strong aluminum weld?
The biggest issue with it, and this comes from every instructor I've been involved with that's done classes for me that I had to take, is cleaning. It's cleanliness. Forget the metal. Your table, the car, your area, the curtains, the air extractor, the air, the ventilation system, and then the air extractor that comes in, all have to be super, super clean. Okay.
Now you clean this before the show. You can see.
Just
it.
real quick.
So
and I didn't use a stainless steel wire brush.
Am I good to go now?
No.
But you already.
Well, first off, I
brushed it.
used the wrong brush, and I just did that just to show how.
But let's
how
say
can
you used
clean
the
it up.
right brush an hour ago.
I'd have to redo it.
Right, so you can't just clean it, go to
So
lunch and come
basically,
back.
this is how your aluminum comes. It's shiny. Okay, I'd have to wipe this off with gloves on with acetone. After I'm done with the acetone, the table should have been wiped off with acetone. Then I can take a stainless steel wire brush, but I have to check my stainless steel wire brush and I have to put a magnet to it. If a magnet sticks to it, I shouldn't use it because it's a stainless coated wire brush, which means I'm eventually going to break the stainless steel off and I'm going to be putting steel into this. So I got to put the magnet on here, and let's say this is a magnet, it should do that, literally fall off. Now I'm good to go, I can use that brush. Now, you're going to brush it, and I only did this a little bit. This is still can't be welded. Even if I just did it now, there's along here, you can see there's shiny material. There's shiny material. It's got to be super, super clean. And the brush gets dipped in acetone and wiped off also. Now I still have my gloves on. Now I'm done, and I might have work gloves on to sand it. I take off my work gloves, I have my plastic, latex gloves on. I wipe off with acetone, and now I'm ready to weld in an area that's been cleaned already, including.
And after I clean it.
You never hit it with a brush again once I wipe it off with acetone the last time.
Yeah, but after I clean it, how long from the time it's clean, ready to go, do I actually have to have the weld done?
It depends on the environment. Most of the courses tell you, look, within 15, 20 minutes, you probably shouldn't let it sit there.
Yep.
Your greasy hands, spittle out of your mouth, whatever, sweat, is all going to screw up aluminum massively when you go to weld. And you're not going to get the right bead with it. So once again, it's cleanliness is the biggest issue. Then it's the clamping and making sure.
But it's also just the atmosphere. It'll oxidize.
Well, the atmosphere is going to get thin. That's why I have to be everything super clean.
Yeah.
When you clamp it together, you have to, especially with this, you have to make sure it's very tightly clamped. Because unlike steel, that's a little more forgiving to the heat, aluminum warps very quickly. And if you don't have it clamped together, or the panel's bent somehow and you got a little bit of a gap there, that can be an issue. And what's going to happen is, it's not going to melt back in and straighten out. It's going to get worse as you get along. It's going to become worse and worse as you go along. So it's cleanliness, and then obviously making sure it's clamped together. You have to have the proper wire that the OEM's going to call out. There's a few different wires out there for a few different OEMs.
So that's. I was just about to reach for that as you were bringing that up. So
yeah, this was 54, 54,
55,
55, 54, 1.2 millimeter.
So this would be, let's see, GM recommends this?
GM recommends that, yeah.
And now, I didn't take it out of the plastic bag. Why didn't they take it out of the plastic bag, Larry?
Why contaminate it?
Okay.
You're going to just contaminate it. There's no reason to pull it out. Don't leave it in the machine. Pull it back out of the machine. Put it away and stuff like that. And you got to keep in mind, you get bird nesting in a steel or even silicone bronze.
Once in a while.
It happens once in a while. You can pretty much, you cut the ends, you pull it out, and it's not that big of a deal. With aluminum gun liners, if I get bird nesting inside the machine, and maybe you can point to where it gets bird nesting usually, show the front portion of that where it gets in there.
Right up in here.
That bird nesting that happens in that area, when it happens, you need to cut it, take the gun liner off, file the edge of the wire you cut so there's no sharp edges, cut the front and file that edge and pull it from the back end of the torch handle. Don't pull it from the front because you're going to drag all that bad stuff through it. Drag it back the opposite way because if you scar the inside, which is usually Teflon, you're going to have an issue where you're going to rip it, or it's a plastic. It's going to rip and it's just going to keep bird nesting and bird nesting, and you're going to waste tons of wire, and it does become an issue. Probably nobody's ever changed their gun liner in their steel unless something really wacky happened.
Right.
With aluminum, you're going to need to have at least 2 gun liners, gun torch setups, in the shop in case something goes wrong. You're going to need, maybe you change a tip once a year on steel or silicone bronze. Aluminum, you're going to need a bag of tips because you will get sometimes burned back and it will melt. So this is stuff that you just can't go out and just weld aluminum the next day. You have to learn how to weld it, how it gets out there, And technique is huge with aluminum, especially where the gun's pointed, especially for the fact that a lot of times you're welding some thicker and thinner stuff together for the structural. And on the outer panel, which on the new Mercedes-Benz, the 222, the quarters went aluminum, you're welding 1 millimeter to 1 millimeter backing to a 1 millimeter panel with 1.2 millimeter wire at probably a setting of 0.7 to 0.9. It's difficult. Now, some companies allow you to do a two-step, weld, stop, and keep going that way. But each time you stop, you have to clean it with a brush for the soot. Weld, stop, weld. Other companies require you to weld a tab on the ends of where you're actually welding and then start and weld across and stop. Not so bad on the thicker stuff. On the thin stuff, really difficult to avoid warping. And you got to keep in mind, most companies require for structural stuff a 4-step weld. And a 4-step weld basically is, I'm going to grab my gun torch, I'm going to squeeze the trigger. The weld's going to start happening like any other welder. It's going to be at 150% of what I set it at. And then I'm going to let go of the trigger once I prevent against the cold start of having a big ball at the beginning. And it's going to drop back down to whatever setting it's supposed to be. But my finger's not on the trigger. I'm not squeezing the trigger, but it's still welding. When I get to the end of the weld, and I got a little bit of space left, I'm going to squeeze the trigger again, and what it's going to do is it's going to increase the gas a little bit, and it's going to slow up the wire to kind of fill in a crater that sometimes I'll go forward and come back a little bit just to fill in the crater, but at the same time it drops the electrical current down. And then I let go of the trigger and the machine completely shuts off. And that's a 4-step process that you need for this on the thicker material. And it takes a little bit of technique to get used to.
It's practice.
You know, and it's a lot of practice and stuff like that. So, like what plug welds, you guys just pick you pick the edge or the middle and make a circle, or start here, go around and finish in the middle. With aluminum, a lot of times I have to start over here, weld into it and wound and finish in the middle because of the cold start. The crater can be in the middle because it can fill the crater in. Some companies actually had it one time, when you're done, there's a crater, wait a second, 1 Mississippi, and just give a fill-in for the crater so you have something to grind down a little bit. It's a completely different technique, but the problem is that the machine looks exactly the same. The principles of it kind of look the same. Just like doing aluminum repair to a panel is all the same equipment, but it's completely different. It's like, and I've given this before, it's like me saying that aluminum and steel is the same type of repair process, the same welding, is like me saying welding steel and welding a plastic bumper is the same thing.
Right, that different.
Right, well, that's how different it is, but because it's the same looking equipment, that's causing the issue that everyone thinks, oh, I can just go and weld this. And people are shocked when they take an ISO test and go, oh, I thought I could weld aluminum. No, you can't, because now there's different parameters for it. You know, they do porosity checks through X-ray. They rip it apart at a certain, pull strength. It becomes a very difficult, and that's why it's so much practice. Right? Yeah. It's an ISO test. It's no joke, man.
Okay, so aluminum strength, we're talking, well, make sure we get the proper electrode wire.
For the aluminum series you're welding. Certain companies call out certain things. Like I think GM and Ford and Mercedes-Benz use the same wire. So literally, if you had it in your machine, you could weld either one. But you can't go weld out against a different wire, which I think is the same as GM. If I remember correctly, I don't have it in front of me right now.
But we want to make sure we got compatibility between the electrode wire and the
material you're welding from the manufacturer.
Cleanliness is key.
Paramount, huge. It's very important with everything. It's a must with aluminum. Otherwise, you're not going to get away with anything.
We want to figure out how to work around a cold start. We want to eliminate the cold start either through a 4-step or through a tab or whatever. We want to eliminate the cold start, and then we want to finish to make sure we have eliminated the crater. I mean, those are kind of the 4 keys to a good weld. And then obviously technique.
If you have one of the machines that are approved, like the Fronius or the CMI 3000 from Carolina, with practice, you're going to see how well these machines were geared and passed that test to actually make it for welding. I even think that there's one other company that's a popular machine now that's out there that are on the Europeans, the Americans, and everything like that with these welding. And it's amazing how well this machine that's really all auto will help you make better welds. Then you can tweak a little bit. You can do plus or minus 1 or 2. and you can dial yourself in on speed and stuff like that, and you can really watch the weld. And body position is one of the most important positions. When you're welding, you have to be at the side looking at the weld, and you see it coming out. With aluminum, you're actually kind of like it's actually shooting you in the face. Or I'm welding overhead, that a big long overhead, I'm actually welding like this. It's like literally coming to my face. Your elbow position, your body position is very important. Because if I'm welding a vertical, you know, like this, if it's longer or if it's higher, and always an overhead should be right at your eyebrow level. Okay, even this should be like right at my eyebrow level, so I can see it. My arms aren't stretched out, and always wear a welding jacket so you don't burn your arms. Right. Flat can be almost anywhere, or vertical. Once again, vertical should just be a little bit below eye level so I can watch it. But as you weld, and don't oscillate. But as you weld with it, if I'm welding in this fashion here, and I'm welding, I can see my middle fingers keeping, you know, parallel to this. But if I start to do this, I'll get porosity, soot, and stuff. So I might have to do this and move my elbow. And like I was saying with pool, it's kind of like, you know, pool, everyone always taught you, your dad taught you, it's a pendulum. Yeah. I move from the elbow down, not the shoulder. And that's going to take my aiming hand away from where it's supposed to be. So if I just do this, it's going to go straight, and I'm going to send the ball where it's supposed to go. So same thing when you weld. Keep your elbow in your. This is all.
So you want to move your shoulder.
You got to move your elbow up and down at your shoulder, not move the elbow, because you get this arcing thing, kind of like when someone stands between two doors and sprays like this. You're getting dry spots on the end, and the middle looks nice.
Yeah. Yeah.
All right. Well, I mean, we could talk about.
I was going to say we can just keep going forever.
Hours and hours. So we're going to wrap it up. Get ready for our next show. We've got Subaru at 12:30.
Subaru Certification.
We're going to talk about Subaru Certification, the audit process. We're going to shop owners' perspective on the Subaru Certification and their process, and how it's different from other potentially certification networks and what Subaru's doing us. So looking forward to that at 12:30 Central Time, and then we'll be back at, I believe, 3 o'clock. And we're going to talk about making practice welds and why it's important.
And destructive testing.
We'll kind of tie it back to this. We're going to talk more about OEM parameters and the importance of
visual inspection, how to look at them, how to correct some mistakes maybe, and then some parameters around destructively testing.
So we'll be back at 12:30 with Subaru.